Hey guys, welcome back to my YouTube channel. And today we'll be continuing our series on Lead 75. And today we came up with a very interesting problem, which is a two-sum problem. This problem asked in multiple interviews. Frankly speaking, I have given a lot of interviews, and all the time I'll get the two-sum problem. If not, then something related to that. So what is two-sum problem? So let me go through the question one. So here, what we'll have is like a nums array where we'll have a array in a different order. Right now it's a sorted array, but it can be of a different order, as you can see in example 2, of a different array. And our problem is to find the index of those two elements which will sum up to the target. So from the now if I come to the logic part here, from the start, our main first thing is like the brute force solution. And then coming to the brute force, what we can do is like we can just simply iterate over each element for each index, and we'll find the sum of the next element. And if we're able to get a sum equal to target, then we'll able to get the solution. But the problem here is, let me just quickly write the pseudo code. So like here is a one for loop, and here we'll have our I, which is starting from 0, and here it will less than numbers dot length, and here we will just increasing I, and this is the for loop. And inside this for loop we'll again have one for loop, which is a j, and which will start from I plus 1 index, and again here like j should be less than nums dot length, and again we are like j plus plus. Now now coming to the logic inside this for loop, again this is for loop, we'll first check like if nums dot I and plus nums dot j is equal to target, then we'll get the solution here and we'll just return it. So we'll need simply here to return, so this will be return new int array. So it's an array, so right, so we have to return it in array format. It will be like I comma j. But the problem in this approach is like you will able to get the answer, but what is the problem we're facing is like it's not the optimal solution here. If we say we are like iterating the element twice for a single solution, so what here the time complexity for this element will be like O of n square, and which is not a good time complexity. We can do a better here. So now coming to the second approach solution, it's like I'm just going down. So what we have is like an array, right? So and it's an unsorted array. So like let me just write it down. So here is 2, 7, 15, 11, and our target is like target is 9. So what I can do is like I can sort this array using the sorting function, and then I'll use the two pointer approach right here. So here like 2, 5, 11, 15, and based on sorting algorithm, here I can get I and here I can check, and for by that way I'll able to get the answer. But that is not the question required. Question says we have to find the index. After sorting the element, we'll able to lose the index value, right? So if I say, for example, here the index value of 15 is 2, but again it's changed to 3. So this is not the approach for this particular solution. If the question says like, okay, we just have to find the two numbers which are like having a given solution, then this solution is a good solution. Now what we can do now, now let's think about one another solution approach, which is like now let's go to as I know, right, we know that like there is like a hash map, like a space and a time thing goes hand to hand. So if a hash map, if I use a hash map, I can able to store the index and I can check for the index. So what I'm saying is like, suppose for before the area of index 2, 5, 7, 11, right? So we have one hash map present here, right? So what is hash map? Hash map is nothing but a table, right, where we have a key and a value. So here instead of like so here our key will be the number and the value will be their index, and as you know like 0, 1, 2. And what we'll do is here like for the target, we'll first find the difference of the target, and we'll difference means like we'll find the difference of the target minus current nums of I index. So we'll check the difference in our hash table here, and if we able to get the number present there, suppose for here that's 2, the index is 0, for 5 the index is 1, for 7 the index is 2. So first for the if I do a dry run, so for 7 the difference will be like difference is equal to 9 minus 7, which is like 2, and it is present in our hash map, right? So by this way we're able to say, okay, so if our element is present in our hash map while we are before putting it, so we can say like, okay, so our sum is present there. If I write a pseudocode here, what I'm trying to say is like, so for loop, it will be like a simple for loop here, where because we are iterating for each and every element. So int I equal to 0, I less than nums dot length, and I plus plus, right? So here, if you can see, we before putting the element, we have to first find the difference. So here it's like the int difference, and int difference equal to nothing but target minus nums dot I. And before putting this the nums dot I into the hash map, we'll first check, okay, if element is present in our map or not. So if map dot contains our element nums dot I mean like difference, this difference, that means we have our element here. So what we have to do is like, we just have, now we have the answer, so we just have to return this element, return new int array, which is like let me just write it here only. So which is like I'll go and write it down here, which is like the key of the map, which, the value of that key. So like map dot get difference, which is the value, and again the jth value or the ith value will be returning. So by this way we'll able to get it. Now if I say this is the pseudocode, we will be following the approach, and by this way, because we are using an hash map, so there is, so first complexity time space complexity will be like O of n, and the time complexity, because we are iterating each element once, but time complexity also will be O of n. So we'll able to convert the O of n square to the O of n. So this is our optimized solution. Now I'll show you the code as well. Let me go to the code screen here, which is this, right? So it's in the code screen, you can see here, right? What we are doing here is like, we are checking the each and every elements here, right? So this is a simple hash map. What we have derived here is like a hash map. I mentioned it here. We are iterating our each flow, and here instead of different, I have mentioned it as a reminder. And before we are putting the element, we are checking in map, like if this reminder is present in the hash map or not. If the hash map is present in the reminder, we'll simply return the array. If it is not, then we'll just put it here, and this will iterate over the whole answer. And if we didn't find any single, we'll return the null value of the answer. So if I run the element, this whole code, so this is the code we are getting back. And if I able to submit it, we can see what is the answer we are getting here. So our solution is accepted, and this is how we have to solve the two-sum problem. Thank you.